Hey guys, welcome back. We just finished this question. Really kind of an interesting bit of a riddle. Now let's take a look at some a more straightforward question. Let's see. I didn't staple these together. Oh, here it is. Okay, so last two questions, 27 and 28. It says, explain the steps needed to construct an angle bisector. So this is just copied right from your notes, so I won't take too much time, but I will direct you back. There it is. Construct an angle bisector. And we saw an example for there's 3 steps. So go ahead and write out those 3 steps one more time. And remember, it's angle A. So they actually called this angle A as well. So you can actually copy this from page 17 in the textbook. And I actually scanned the textbook for you. So even if you're at home, you don't have a textbook, I scanned it on this assignment. So make sure you show me one more time, and this is how we learn, just a little bit of repetition. Write out the steps, explaining these steps, and you can use slightly different words if you like your words better than my words or the textbook. And then actually show those steps. So I believe it's step 1. I'll use my paper clip. Make an arc. Okay. Step 2. Oh, still part of step 1. I got lines and arcs that cross, so I'm going to call that BC. Step 2. Make some arcs out front. Okay, so you write that there. Make some arcs out front, and I'm going to do that with my paper clip. So here out front of A, I'm gonna make an arc from B, and then I'm gonna do it again from C. And if you didn't catch that, it's on video now, so feel free to rewind. And then X marks the spot, right? So I have 2 lines that cross. So let's look here in the notes. I got 2 lines that cross. I gotta label that D. And now I'm done it. I'm gonna get out my straight edge. And I really can use anything that's straight. Thanks, guys, if you filled out that essay question. And if you haven't, make sure you go in and fill out the discussion question so I can grade that. And you use the straight edge to connect A and D. And looky there, that black line looks like it really does cut angle A in half. So make sure you fill in each of those steps and go ahead and practice the construction. That'll help you prepare for any quiz or cycle assessment we might have on bisecting an angle. Now let's look at our last question in the homework this week. A perpendicular bisector, so that's cut in half, and perpendicular means at a 90-degree angle. So if I had a line segment here, this purple line would be a perpendicular bisector because it looks to me like, and this time I can get out of a ruler, it looks like the left is 1 centimeter and the right is 1 centimeter. So the purple line cut the black line in half and it did it at a 90-degree angle. So this is what a perpendicular bisector means. And I'm going to give you an example of what it doesn't mean, because that helps our brain see and understand better. So here's an example of not a perpendicular. I'm going to make another little line segment. It's short. It looks like about 1.5 centimeters long, right? And what if I did chop this thing in half, but I did it at a weird angle? Now it looks like I have cut it in half, right? This looks like the midpoint there, but the pink line is not at a 90-degree angle. Okay, so hopefully if you had a little confusion about what perpendicular bisector means, that clears it up. A little bit more clarification. Now let's take a look at, if we understand this better, we can tackle this question. A perpendicular bisector of DC is AB. So I'm going to just draw that. Let's just make a quick sketch. What if DC was cut in half by line AB? So again, notice I tried to make AB hit right in the middle. So this would be the midpoint. It goes through the midpoint. And I did it at a 90-degree angle, not lopsided. Then it says, and a perpendicular bisector of segment AB is DC. So let me flip my paper here. Does it make sense that did I draw AB that DC cut it in half? And it looks like, oh, I got close, didn't I? So I can adjust my picture. I'm using some of these strategies, right, that I mentioned earlier. I'm gonna adjust my picture and draw what they're asking. So, and I could use a ruler to just make sure, yep, so that looks like 1/2 inch to the left, and I'm gonna just make 1/2 inch to the right. Beautiful. Okay, so this would make this a true statement of a picture of what they're describing. If a perpendicular bisector of DC is AB, and if it's true that a perpendicular bisector of segment AB was cut in half by DC, then the intersection of AB and DC is E, so they've asked us to call that E. Which equation is true? Is it true that AB, this whole length, is equal to ACD? Well, that's actually not true. I actually drew a picture that made this true, but A false. I mean, I could have driven it, but I drew CD as 2 centimeters long, and I drew AB at 3 centimeters long, but they're both still perpendicular bisectors. So this is kind of not necessarily. CE and CD. CE and CD. That can't be true. CE is half, and CD is the whole thing. So half is not equal to the whole. This 1 centimeter is not equal to 2 centimeters. Now let's look at C. DE is equal to CE. DE is equal to CE. Well, yes, we like that one. I'm going to shade it in. We said that AB is the perpendicular bisector. So this sentence, AB is the perpendicular bisector, that tells me that that one has to be right. Now let's take a few more looks just to prove these other ones wrong, because we know on the midterm and the end of course exam, they like to throw in check all that apply. AE is equal to DE. AE is equal to DE. Well, I drew my picture where that's not true. AE is about 1.5 centimeters. DE is only 1 centimeter. So it's one of these, not necessarily. And EB is equal to CD. Once again, this here is not that this is 1.5 centimeters. This one I made 2 centimeters. So I'm gonna have to say one more time, not necessarily. That's it for homework, guys. I appreciate you watching the video. I hope it brought clarity both to the lesson, the example, and the homework. See you guys next time.